Bismillahirrahmanirrahim. Exercise 4.5, question number 7. Find the joint equation of the lines passing through origin and perpendicular to the lines x square minus 2xy tan alpha minus y square equals to 0. Let's see what do we need for what is the knowledge which we need for solving this particular question. We must know that equation of a line passing through origin is y equals to mx because its x-intercept and y-intercept both are 0, and this the equation simply becomes y equals to slope of the line multiplied by x. Then if the lines represented by ax square plus 2hxy plus by square equals to 0 are L1 and L2, where m1 is the slope of L1, m2 is the slope of L2, then m1 plus m2 simply becomes minus 2h by b, and m1 m2 equals to a by b. That is, sum of the slope is minus 2h by b. You may get the value of h from here and b from here, and m1 m2 is equal to a by b. You will get the value of a from here and b from here. Third thing which we must know is that if m is the slope of a line L, the slope of a line perpendicular to L is minus 1 by m. Now let's start the solution. We are going to write the given homogeneous coordinate equation x square minus 2xy tan alpha minus y square equals to 0, and we name this equation as 1. We compare it with the standard homogeneous quadratic equation, which is compare with ax square plus 2hxy plus by square equals to 0. And this comparison gives us that the value of a is 1. You can compare these two. The value of h, compare these two, and you will get that the value of h is equal to minus tan alpha. Just compare it xy, 2 and 2, and in place of h we get minus and tan alpha. And the second and the third thing, the value of b it becomes minus 1. Now let L1 and L2 be the lines represented by 1. This is the line, the homogeneous equation 1, with slopes m1 and m2 respectively. That is, the slope of L1 is m1 and the slope of L2 is m2. Then by using this result, then we must have m1 plus m2 is equal to minus 2h by b. Put the value of h here, which is minus tan alpha, and the value of b is minus 1. We perform some simplification, which is that this minus sign, I'm going to cancel this with this one. And as a result, what I get is this 2, and then I open this bracket and I get tan alpha, and this negative sign of tan becomes here. So this is the value of m1 plus m2. Now, and m1 m2. What is m1 m2? A by b. So I get m1 m2 is equal to a by b. What is the value of a? It is 1. The value of b is minus 1. So the result is minus 1. Now the slopes of lines, the slopes of lines perpendicular to L1 and L2 are The slope of L1 is M1. So the slope of line perpendicular to L1 will be minus 1 by M1. And the slope of line perpendicular to L2 will be minus 1 by M2. Now the equations of lines. The equations of lines passing through origin and perpendicular to L1 and L2 respectively. What will be these lines? You can use this equation. Slope of line passing through a region is equation of line passing through a region is simply y equals to slope into x. So slope of one line is minus 1 by m1. So equation of one line will be y equals to minus 1 by m1 into x. And the equation of the second line will be y equals to minus 1 by m2 into x. So we get these lines as y is equal to minus 1 by m1 into x and y is equal to minus 1 by m2 into x. We just adjust the shape and I get one line is this and the other line is this. M2 is equal to minus x. Again, a little adjustment and this becomes m1y plus x equals to 0 and m2y plus x equals to 0. Now, these are the equations of lines perpendicular to the lines represented by the given equation. We need their joint equation. So, for joint equation, just take their product. So, joint equation becomes m1y plus x multiplied by m2y plus x equals to 0. Just take the product. You will get m1 m2 into y square. Multiply this with this. Then this with this and you will get m1 xy. Then this with this and you will get m2 xy. Then this with this and you will get x square equals to 0. Now, I'm going to write this again as x square plus m1 plus m2 xy. Take xy common from it. And then comes this term. m1 m2 y square equals to 0. Now, put the values of m1 plus m2 and m1 m2. What were these values? Let's get back and see these. The value of m1 plus m2 was minus 210 alpha and the value of m1, m2 is minus 1. So we get these values here and I get x square plus m1 plus m2 is minus 210 alpha and then here it is xy. The value of m1 plus m2 is minus 1. As a result, I get this equation x square minus 2 tan alpha xy minus y square equals to 0. And this is the required joint equation. That completes the solution.